Hey everyone, Paul here for our second video and our second assignment for this week. So our first one was about complete graphs, and now we're going to look at something called a bipartite graph. Okay, now a bipartite graph is a graph that has two sets of vertices, often referred to as a left and a right, where each left vertex is only connected to right vertices, and each right vertex is only connected to left vertices. The main idea, right, is that all three of these like left vertices, right, don't connect to each other. They only connect to right vertices. And the right vertices don't connect to each other either. They only connect to left. So like this space will always be empty if you have a bipartite graph. Now you guys have seen bipartite graphs before in one of our first assignments. We had these matching activities, right? I don't know if you remember this, but we looked at how you can try to create like a matching and a pairing between these things here, where A was like people and with capital letters were people and lowercase letters were like jobs or something, right? So we've seen these before, and you've done a few questions on them, but we're being a bit more specific now about what exactly they are, right? So some bipartite graphs are really easy to see because they're already structured in this like left-right fashion. But what if they're not? What about this graph right here? Is this graph bipartite, right? Does it satisfy the condition where has two sets of vertices where each of like column one vertex is only connected to other ones, right? Let's see what we can do to see if this graph is bipartite, right? Maybe you can see already if it is or isn't. I'm going to do it with our graph editor. All right, so here's our graph editor. I'm in edit mode. I've copied this same graph. And all I'm going to do is I'm going to kind of just like, okay, so I'm going to put the A vertex on the left side, and then each of the vertices it's connected to, F and B, I'm going to pull over to the right side. Okay, and then each of the vertices that B is connected to, I'm going to pull over to the left side, right? And each vertex that F's connected to, I'm going to pull over to the left side, and then DL pull over to the right side, and there you go. We can see that in fact it is bipartite, even though when you look at it in its original form, it's hard to see. So if you want to use this editing tool, right, the online graph editor, you can. It's really nice for this. Please notice I'm in edit mode. If you do this in draw mode and you click a little bit weird, you'll make an extra vertex, which is not what you want to do. So whenever I'm moving my vertices around, I always do it in edit mode because then you can't accidentally make a new vertex. Okay. The other thing you can do is that same kind of process, but instead of dragging the edges around, you can just sort of recreate the graph. So I'll start by putting in vertex A. So this is my vertex A. And then, yeah, I need like 5 minutes, okay? Uh, and then I'm going to put in the vertices it's connected to, which are F and B. So I'll put F and B over here, and I will connect them, just like what we kind of would do. It's like I'm rebuilding the graph, right? And I'm a little slow about it because, you know, this is not the easiest thing to do. F and B, and then I'm going to look at B and see if there's any vertices. Oh yeah, so B is connected to C, and so I'll put in a new vertex and I'll label it as C, right? And then I'll draw in my line. Try to make this thing really neat. F's connected, or C is connected to B, and then I'll look what C is connected to, and you can see like we'll end up just sort of getting this exact thing that we had in the past, where each, right, C is connected to D. This is D right here, right? And then D is connected to E. This is E right here. And then E is connected to F, and we have a bipartite graph. So you can either kind of stretch the graph around and move it, or you can like recreate the graph step by step. And if you end up getting this bipartite, like left and right sided graph, it's bipartite, okay? So that's one method. So one method that I'll say to see if a graph is bipartite is you take the graph and you just make it into a left-right grouping. And if it doesn't end up having the left and right grouping, it's not bipartite, right? This is easiest to do by starting with the vertex and recreating the graph by adding in each vertex it's connected to. Repeat, that's exactly what I did right here. Okay, I started with A, I put in F and B, I then put in C, I put in D, I put in E, and we were done. The other thing that you can do to see if a graph is bipartite is you can look for a circuit that is odd. If you find one, the graph is not bipartite. So this kind of prompts a little theorem that we can look at real fast, right? Theorem, a bipartite graph has only even circuits. And the flip side of it is a graph that has only even circuits is bipartite. So this can be really nice because it sometimes is really easy to see that graphs don't have even circuits. If we look at this one here, is this graph bipartite? Well, that's a lot of vertices, right? That's 4, 5, 6, 7, 8, 9, that's 10 vertices. I don't want to do that thing, so I just look to see, okay, is there an odd circuit? Oh, there's a circuit that has a length of 3, so no, it's not bipartite. And I could just say really simply, if I wanted to like explain it, how I know it's not bipartite, right? I could say A, C, D form a circuit with, I can't type today, circuit with length 3, right? That is basically enough to say that it's not bipartite. No, A, C, D form a circuit with length 3, right? Now, if you're really feeling lazy and you don't want to actually draw a bipartite graph, you could just say a graph is bipartite, and you could kind of say like left vertices are A, C, E, right vertices are B, D, F. Okay? Like from a graph theory standpoint, this is kind of the same thing as drawing the graph. So you can either draw a graph or you could kind of give the left and right vertice splits. Okay, make sure you can fully see that, right? So this thing right here is effectively the same thing as this thing right here if you're just trying to answer the question, is it bipartite? Okay, one last thing. We talked about complete graphs. We talked about bipartite graphs, and now we're going to look at something called a complete bipartite graph. So a complete bipartite graph is a bipartite graph where each vertex in the left group is connected to each vertex in the right group. So here we have 4 left vertices, and here we have 4 right vertices. And if we were to draw in the complete graph, it would look like that. It's a lot of edges. Notice every vertex here, right? Every vertex here on this side is connected to every single vertex on that side. Okay? The notation for this is a capital K and then 2 numbers, A, B, right? Where we have like the left and the right. So question, how would we name this graph right here? Well, it's going to be a K. It's going to be K, 4, 4. This is the graph of K, 4, 4. And you could have K, 4, 3, and K, 5, 4, and K, 6, 10, and whatever. Every pairing would have a name like that, okay? And again, you're going to do a little bit of exploring with complete bipartite graphs. It's like just kind of thinking through how this stuff works a little bit, okay? I tried to make it not be too much this week, but I'm sure you'll let me know if it is. Hope everyone's doing well. See you in class.